Thank you, Tony, for giving a Cliff Notes version of everything we're going to say tonight. I do want to thank Sarah Hess for putting this together. She evidently doesn't want to be thanked, but I never behave anyway, and I want to thank Irene Weiser for helping putting this together. And while we're looking at that map, I wanted to point out that Karen Edelstein basically maps our world, and that's one of them right there. So here's to them. As Tony pointed out, what I'm going to talk about is the geographic extent. I know we're in the geology building, but I'm going to talk about the geographic extent of shale gas. Try and put it in because it's funny. Most of us at least, live on the surface, and we're concerned about the biosphere and the two-dimensional aspects of this. So I'm going to start kind of at the surface. The first thing that you may have noticed years ago is that all of the popular press talked about the Marcellus Shale and the Utica in expansive terms geographically. All the maps, and this is that's a newspaper clipping, always talked about it as if it went all the way up to the Mohawk, which of course it does, but the implication was that it was going to be productive, it was going to be drilled. And the people in the industry know, but they didn't probably admit it, that never would be the case. So we look at what the sort of the drivers of drillability are, and they are, as Tony pointed out, the first one is the geology. If the rock ain't there, then don't go there. The second one is, of course, the economics. We're going to touch on that a little bit. The one that people don't really think about, other than Karen, is they don't map what the impact of the regulations are. I mean, some people moan about them, some people cheer about them, but they don't really think about it in terms of the impact of the drillable area. We're going to touch on that too. Of course, I'm going to defer to Brian and the smarter guys on the geology, but that happens to be a map of the high carbon content interval of the Marcellus. The Marcellus is 2 layers, and that's basically the target layer. That's an isopack of the thickness, and nobody can read the legend. Well, maybe you can read it actually, but it shows you that it stops pretty much, or it goes very thin, just north of the border. So the interesting thing about shale is, as opposed to conventional or vertical drill reservoirs, is of course obviously is the area itself they can be massive, and the Marcellus certainly is massive, but that can be of course misleading, as you saw in the first slide. The productive area of it is uncertain, the optimism creeps in, and people think, well, it's going to be all over that place, and that's probably what some industry proponents would like for you to think of. The reserves, of course, are always speculative. But one thing is, and the reserves, by the way, is one thing we're not going to talk about tonight. I mean, we're really talking about the geographical impact, the spatial extent of it, not the volumetric extent of it or the volumetric potential. We're not talking about reserves. But one thing you can be sure of, irrespective of the reserve estimates, is that spatial extent always starts at the maximum, and it shrinks, it consolidates. And this just to give an illustration that obviously a vertical well is tapping a trap, which is usually fairly, even in Saudi Arabia, is fairly limited geographic area, whereas a shale, when it's initially explored, it could potentially be, or at least from the lay terms, be anywhere over a very large area. The hot shale before the Marcellus with the Haynesville, which happens to be in East Texas and central Louisiana, and its spatial extent was that's where the shale was, and so initially people thought it was going to, well, some people, again, the laity, thought that it would be over that entire area. Very quickly, as soon as it started to be tested, it consolidated to basically the corner of 3 counties in central Louisiana. That play in particular is basically played out, at least economically currently. But that's indicative And that just happened to be the hot deal before the Marcellus, but that's kind of what all of these shale plays, whatever, the Bakken, you name it. It's the nature of the beast. That's the Marcellus in Pennsylvania, southwest hotspot, northeast hotspot, and it's already started to consolidate. And frankly, that's where Jerry's model picks up on, is how you can map that and predict that consolidation. And of course, he's going to talk about how that consolidation impacts New York State. Then we've got the second constraint, other than the geology, is the economics. And we're going to drill down on that a little bit. But of course, it's the commodity price, and it's the full cycle cost of producing the commodity. And then the net out of that, or the reduction of that, is the last thing we're talking about, which is the regulatory constraints to that geographic area. You know something, that slide is wrong. There's more to it than that, I think, Mr. Podolka. I'll have to ad lib. That's kind of, well, that's funny, that's those first two, because that's all you see, that's all you hear, really, is you've got this huge area, and then what you read about in the press, even today, whatever AP comes up with, is you hear about the gushers. And I mean, that's the nature of the media, it's dog bites man. But the problem is that the rest of the story, the rest of the slide, is that's not really what happens. What they are trying, well, the drilling, the operators are trying to do is they are trying to pump that up. They've got all this area leased up, they extrapolate their winners, and then they flip it. And that's number 3. And then number 4 is they go back to step 1. And I'm not talking about some, penny stock. I mean, even the big companies, or the big companies that are pure play shale companies. And the way that happens is that basically what they do is they go and they test a well that might be, so say yellow is about average, green below average. These are tests over, say, a large area. That's above average, below average, average. And then guess what? And then they get lucky. And then guess what happens? So now that becomes the producing well. The rest of them are test wells. Lou's going to talk about test wells in a minute. That's the one that they hook up to the pipeline. That's the ones that they produce. That's the ones that they report to the government. And then guess what happens to those leases? That's how the lease gets sold. And I'm talking about billions of dollars worth of leases. That's how they get sold. And of course, I told Sarah I wouldn't get political, but I mean, then the shareholders hold the bag on that, whoever bought it. This was enabled from the sort of like the, what do they call it, the housing bubble, the subprime bubble, because of something that happened in an accounting change that, fascinates people like me and puts everybody else to sleep. But basically, the SEC changed the rules on how you can book these unproved, undeveloped reserves. All that other acreage that wasn't producing, other than that hotspot. And what they did, that simple rules change, which happened in October 2008. Now, let me think, whose watch was that on? That tripled the reserves on paper within a matter of months. Now, the question is in fact this, is the Marcellus, is it economic at all? And the short answer is as uneconomic as some of it is, it happens to be one of the most economic shale plays in the United States. The Haynesville that's by the way, that horizontal line was at the time that the merchant bankers that pushed this out to Wall Street sent this thing out. That was the commodity price of gas, $4.50 a thousand. And those bar charts is the fully loaded cost of developing that, of producing that. So anything above that line, which is, $4.75, call it, what is uneconomic. So the Haynesville that we talked about at the beginning was already uneconomic when this thing came out, a year and a half ago. In fact, a year and a half or so ago, the only three that were productive or were cost effective was the Eagle Ford and those two Marcellus, the southeast and the this is gas, by the way, and the southwest and the northeast. Does that make any sense to you? This, by the way, is the producer break even. This is not necessarily the fully loaded, but this is the average well, not the financial accounting of it, but just the average well. And we'll talk about that in a second. Now, there's different break-even scenarios here. I got to, get carpal tunnel on this one. Now, here's the thing. So we have this, this extrapolated production from that gusher, and I call it the PR because the press release on this well, the one that you all read about, is that it breaks even if gas is at $5, or you'll hear a hot well down in Bradford County, it'll break even at $1.50 or something. Well, might be true, in fact, for that one well that, Gannett or A&P, or AP, showing my age, that's what they would advertise. But that isn't, in fact, that's not even what it is to the company. If you fully load the cost of that well, you put in, lose salary at Mobil and all the overhead and all the exploration costs, then the cost of that, from the financial accounting standpoint, would be more like 7. So they don't, you're not going to read a story in the New York Times that a well was hit in Pennsylvania. The fully loaded cost at the corporate level was $7. I mean, I would, and Deborah Rogers would, but nobody else would. But there's more to it than that, because think about it. You've got all those dry holes that were drilled, not by this company, by all those companies that flip leases, went out of business, or that hit dry holes and went out of business. If you add those costs from a systemic, Jerry didn't want me to use that word, but I will, from a macro standpoint, and you throw in the remediation costs of cleaning up the mess of all those wildcat wells, then the cost of producing that gas goes up. And I'm not even talking about, Al Gore's carbon tax. I'm just talking about the overall cost of producing that gas. So, this is from the Energy Information Agency that's gospel to everybody because it's basically just a composite of numbers that the industry gives the government. And so that's a projection, sort of a high, medium, low scenario for gas price. And as you can see, again, sort of the sticker number for around here is like $5 an MCF for these Marcellus wells to breed. So, okay, so it's $5. So, we're looking at 2025. And that's not the financial accounting cost. That's not the fully loaded cost. That's just what the PR people say it would be. So, okay, so it's 2025. But there's a price inelasticity comes in. You can't deal with this in isolation. What happens is people think, well, yeah, but it was at 12 and it'll go to 30 someday for my grandkids. Well, I don't think so, And the reason why is because you've got coal down there crawling along out to 2040 at like $4, whatever it is, a million BTU or however they price it. And you have alternatives. You have renewables with the price coming down. So basically you have the cost of coal constraining the upward price of natural gas in this company, like it or not. And you've got renewables that's basically serving as a cap to the price escalation of that commodity. Something like that. This is Lou's idea and this is Jerry's graph. They let me present it because I was the tallest. Then you have the regulatory limits. And again, this is, I'm the biggest complainer about this, but you have this sort of this debate about whether regulation, but people don't think about what the net impact is. You've obviously got the proposed state regs, the S guys, the drilling, fracking regs, whatnot. You've got the valley districts, not the valley girls. And then you have local ordinances like, God bless them, Dryden. That people think they focus on kind of the big headlines, and of course that's New York City and Syracuse watershed. It just takes out a Boku drilling area. But then there's state forests and whatnot that are riparian districts and whatnot that reduce that area. And then you have even the proposed state regs, which I will not make an editorial comment on at this time, because I promised Sarah. But if you net those out, then what you find is, and of course you've got these river districts, is that, and a very good study was done on this, is you take those and you map them out, and just really in theory, not literal, not in the way Karen maps stuff, but you map them out, then it shows what the net reduction of drillable area would be. Just to propose regulations. Now what's interesting is if you get into an area that has a high population density, and for illustrative purposes, you normalize that over the entire area, you find that given the setbacks from housing, you can't drill any wells there. I mean, you didn't need me to tell you that. But I mean, you can in theory begin to get a sense of what that impact is. The other one is, and it's kind of a funny one, is that, if you drill one of these horizontal wells and you hit a vertical well, then you've recreated the Trevi fountain. And so the DEC is not unmindful of that fact. And so there's a 1 mile mapping setback from any existing vertical wells, meaning you've got to show that you're not going to hit that well with a horizontal. But the funny thing is that if you go to some counties that have been drilled up as much as East Texas, like Chautauqua County, that means you can't drill any horizontal wells, because there's no place you can drill a well down there and run a lateral and not, recreate Old Faithful. And then of course there's the Delaware, and these are examples. Delaware is 58% reduction drillable area. Chautauqua County, in theory, is almost 100% reduction on drillable area, again in theory. And then I picked the one that I happen to be familiar with, Otsego, because of population density, a huge reduction in drillable area. And this is with the regs as proposed. So you end up, again, this is in theory, you end up with an 83% reduction in drillable area in New York State versus a theoretical reduction of 35% in Pennsylvania, just based on existing regs. Now, the catch is that you can't normalize density so that, there's one in a county or in a SMSA where there's one house neatly placed every 200 feet, unless you live in a suburb. And Karen did this one because obviously under the existing regs, if it's say there's a 500-foot setback from a house, then clearly you could. I mean, it's just a matter of how you're clever about it. Oddly enough, in this map, those three houses would have to be either somebody would have to be all, gung-ho about this, or one of those guys might have to have been compulsory integrated, and if in fact the well was drilled there. But that's another story. The point is this, is it, certainly at a local level, at a township level, you could map this, and from a comprehensive land planning standpoint, it would be a good exercise to do it. And then of course, and this is, mind you, all this is before we talked about the bans, which are basically prohibitions of heavy industrial use. In red, the purple, which are moratoriums, are the same, and the yellow, which are ostensibly initiatives in that direction. Some of these, if these laws are well written, if they go to the quote ban stage, then they would also address road use, disposal of frack waste, waste treatment in municipal water plants, dumping drill cuttings in landfills, that sort of thing. These are tangential, obviously, limitations to drilling. They're not as direct as, say, the prohibition of the drilling itself. So what is that? And what's the net effect? And the effect is that you can kind of get a sense of this by looking at what the drilling apps are for horizontal wells in the state. The DEC keeps a file of it. And so that's clearly an indication that somebody wants to drill a well there if they pull an app permit. The apps, the curious thing about the apps is they only really reflect the geology. The company thinks there's something worth drilling there. They do not, they may partially reflect the economics because those may be old apps. You know, they may be $12 an MCF apps in an old lease. They may not really reflect the company's intention. They don't particularly want to remove the app from the queue. And then they really don't reflect the restrictions that we talked about. Because remember, the only thing it takes to get an app into that queue is that you just got to show up with 640 acres, a section, a square mile. Yeah, you don't have to, say that you're not going to kill any snail darters. And what's interesting to me is you look at those apps, which, wonks like me do, and you see that there's very few of them that would really be viable in this state. That happens to be an Exxon XTO, a well over in the Catskills, that also happens to be in the Delaware Valley, right upstream from the Josh. So the geology, as Jerry is, what are y'all laughing about? Josh is my buddy. Jerry's going to talk about how that's a geological possibility, that well location. The economics, I don't know, maybe not. Exxon's got the money to spud the well, but the restrictions, I think, might kill that app. I mean, if it came to that standpoint. And that's indicative, but think about it, where we started with a map of everything, from the border to the Adirondacks, from the Mohawk to the Hudson. And that's kind of it. That's Exxon's only remaining app in the queue in the whole state of New York. So, noodle on that. Yeah. And I'm going to turn it over to Brian. Thank you.